Hello fellow chemists, I, Jose Rodriguez, I am back to present another lab with you guys. So this time we are doing the molecular orbital theory worksheet. So we start off with model 1. So this is a model right here, as we can see. This model 1 is bonding in S-block diatomics. So the molecular orbital diagram for a diatomic is made up of two S elements, which is shown below, the diagram I just showed you guys. So we had to figure out the bond order and is the species stable from the list of species given to us. So the bond order will equal half times, in parentheses, number of bonding electrons minus number of antibody electrons. So we use the mode diagram and the definition of the bond order to complete the table below. They give us a list of species right there. The first one is Li2+, so it's lithium. So for that bond order, it came out to be half. And this species, was the species stable? And yes, it is stable. Then we move on to just Li2, and that bond order came out to be just 1, and it came out to be stable as well. Then we move on to beryllium ions. So the Be2+ one, the bond order was half, and it came out to be stable as well. And then Be2, we're still in the beryllium ion, the bond order was 0. And this is the only one that came out that was not stable out of the 4 species given. So what is the maximum bond order that is possible between the two S-block elements? So the maximum bond order came out to be 1, as you can see in our table, because thinking Li2, so that is the maximum bond order, 1. So then we move on to model 2. Model 2 this time is bonding in P-block diatomics. So we have different types of orbitals. So we have orbitals that are symmetric around the line joining the 2 nuclei, or we have orbitals that have a node along this line. Right here you can see the signs given. We have the sigma right there. So bonding and anti-bonding molecular orbitals. So then we move on to the mode diagrams. The mode diagram, it was given with these pictures right here, and we had to figure out along the way. So the mode diagram for Li2, Be2, B2, C2, and N2. So we start off with 2pz, then go into 2px to 2py, 2pz, 2px to 2py to 2s, and then finally to 2s. Then we move on to another mode diagram. That mode diagram is for O2, F2, and Ne2. So we start off on top, it will be 2pz to 2px, 2py, then down to 2px, 2py, 2pz, then 2s, and then 2s. And then I want us to label the orbitals on the diagram like how I showed you before with the sigma signs. Right there. Okay. And as you can see on the mode diagram, I placed them next to them, which belongs with which. So then we move on to calculate the bond order in the molecules below. So they give us the molecules below. So we have to figure out from C2, N2, and O2. The bond order for C2 came out to be 2. The bond order for N2 came out to be 3. Then for O2, it came out to be 2. Then we move on to which of the following species has a stronger bond. So for the first ones that we compare is C2 or C2 minus. C2 came out to be the stronger bond with 2.5. Then we compare N2 and N2 plus. The stronger bond was just N2 and it equal to 3. Then we move on to the C, which is O2 or O2 plus. We compare those bonds now. And the stronger one came out to be O2 with 2. That is the bond. So what is the maximum bond order? It came out to be 3, thinking N2 right here. And that is my lab, and thank you guys.